All right, hello everyone. My name is Timothy Leetgrant, and I have not done a Leetcode video in quite a while, maybe like 4 days. So I know I need to do it. I need to get back into it. I enjoy the projects a lot more, but Leetcode, it's you just got to do it. So let's jump right in and let's continue on our neat code path. All right, so. We are doing this one, the arrays, and next one is valid Sudoku. Okay. Let's figure out what's going on and try to solve it. All right, valid Sudoku. You are given a 9 by 9 Sudoku board. A Sudoku board is valid if the following rules are followed. Each row must contain 1 to 9 digits without duplicates. Okay? Each column must contain 1 to 9 without duplicates. Each 3 by 3 sub-box of the grid must contain the digits 1 through 9 without duplicates. Return true if the Sudoku board is valid, otherwise return false. Okay? No, a board does not need to be full or solvable to be valid. Okay, so the normal rules of Sudoku apply here. So like, for example, this row right here, it would have a 1, a 2, a 3, and there has to be, oops. So this row will have to have 1 through 9. So a 9 will be somewhere here. But notice a 9 couldn't be here because there's a 9 in this column. So each each row has to have 1 through 9. Each column has to have 1 through 9, but each row and column cannot have two of the same number. Similarly, like each of these little boxes have to have 1 through 9, like 1, 2, and then 3 will have to be somewhere, 4, 5 will have to be somewhere, 6, 7, 8, and 9, right? So the question here is it valid? There are 2 ones in the top left 3 by 3 box. Ding, ding. Okay, so there's a 1 here and a 1 here, so therefore it's invalid. So like there was a 1 here and then there was a 1 here, so that makes it invalid. So I'm guessing that I don't right here, a board does not need to be full or solvable to be valid. So is it asking like, is it possible to solve it? Or is it just saying, is it currently in its state, does it follow these 3 rules? As to my understanding, it means, does it just follow these 3 rules? Okay. So now how do we do that? I mean, the brute force method, I would just, oh, that's a terrible way. Like if it's 9 by 9, I could just create like 9 row variables and 9 column variables, and then create one, or not one, but 6 of these, like I guess box 1, box 2, box 3, 4, 5, or sorry, 9 of these like here, and then just for each of the bang, 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 I have to check the row and the column and the box, which is what? That would be M by N. So for each element, I need to check uh, row times column times box size. Okay, and I need to do that for every single element. So it's number, like row, column, box size times number of total elements, which is a terrible, terrible time efficiency. But there are data structures that don't have, or that have O of 1 lookup time. So maybe I can use one of those data structures. But I just feel bad about creating so many of them. Like I need to create like 3, 6, 9 columns and 9, or sorry, I guess 9 rows and 9 columns and 9 boxes. So I need to create all of like that many sets. Like this just doesn't feel right. It feels like there's some other solution that they're gonna want me to do. I can't think of it. Constraints here. But what would the time complexity be? It would, and is there a constraint on time complexity? No. So the time complexity would be if adding is O of 1, if searching for inclusion is O of 1, which actually, let me check that. I need to make sure that like is checking for inclusion in a set big O of 1 time complexity. Let's see. I just want to make sure that it is, because if it's not, it kind of throws everything out. Yes, checking. Okay, so it is O of 1. Okay, cool. So I guess we don't have any other option but to do that. And then, so we're going to try to code it out and do it the way that I can think of. Okay? And then we are going to go and look at the solution and try to figure out how that works. So let's do this. So row 1 equals set, and then I just copy and paste this 9 times. So row, I'm just gonna call it like this, and then so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can see why this doesn't feel right. 2, 3, 4, 5, 6, 7, 8, 9. We're going to do the same thing for column equals set, okay? And then copy and paste this 10 times, or 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we are going to create 9 boxes. So box equals set. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we created the data structures. Oh, what is the memory or the yeah, so what is the space complexity of this? So we are creating 9 rows, 9 columns, and each of those sets contain how many like one row is how many there's going to be however many columns there are elements in that row element. So it's row number of rows times number of column, and then column times number of row. So that's what, like row times column squared. Okay? Yes. Now, it would be, you have number of boxes as well. So that's going to be, I know it's each one is 9, but I'm trying to abstract it to more like, I'm trying to think about it more in the abstract. Like, what if it wasn't just nine elements here and 9 elements there? Like, how does that actually scale? Okay, anyways, so for element in, what's our data structure here? Board. So it's a list of list and strings. Element in, so for row element in board, okay, for column element in row element, okay. So I can either have a dot or a number. If column element is equal to dot, pass. Okay? So do nothing. Else, it's a number. So now, number equals int of this string. So column element, okay? Then I want to put this in its corresponding column, row, and box. Oh, jeez. How am I going to put it in the box? So I know I can do enumerate like this, and then board. And then same thing here, like enumerate row element. Row index, column index, okay? So then what I can do, oh my goodness, no. I have to do like a large switch statement now. Like, does Python even have switch? No. Like if row index equals 1. Oh my goodness. We just keep getting further and further. Like, this is not the solution. This is a horrible. No. I'm trying to look right there, right here to see can I think of any other way to do this? Because I'll need to do 1 through 9 for row, and then which row set to put it in. Then I'll need to do 1 through 9 column, figure out which column I need to put it in. Then I need to figure out, based off of the row and column, which box it's going to be in. Okay, whatever. So we have here, if row is in here, then what do we want to do? We want to do row 1 dot add number. Okay. Actually, I want to say, like, I want to check, like, if row 1, no, if number in row 1, if my number is already in row 1, then we return false. Otherwise, we add that number. Okay, so now we get the privilege of going through and doing this to every single row. So I'm just gonna delete that and copy this. So this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9. There we go, 9. Okay. So 1, 2, 2. Oh man, I missed this one. 2. 3, 3, 3. 4, 4, 4. 5, 5, 5. 6, 6, 6. 7, 7, 7. Okay. 8, 8, 8. 9, 9, 9. All right. Now we get to do the exact same thing for all 9 columns. So now, if column index is equal to 1, if number in column 1 return false. Okay, now else column 1 dot add number. and it's that same number. So now I want to get rid of all this. So delete U. Actually, I can just go like this and copy it and then delete it. Like this. Okay, so delete U, and definitely now delete U. Okay, so you are 2 right here. So 2, 3, 4, 5, 6, 7, 8, 9. All right, so 9, 9, 9, 8, 8, 8. My goodness, this goes against everything that I like. 7, 7, 7, 6, 6, 6. So I have a question. Do you guys think by me posting this video, it's kind of like disqualifying me from ever being a software engineer? They're gonna look at this and say, okay, this is the quality of code this guy writes. Nope, never hire this person. Okay. If number in column 5, 5, 4, 4, 4, 3, 3, 3, 2, 2, 2, and then 1 should be there. Yeah. Now guess what we get to do? We get to try to determine which box it's in. So now we have to use the modulo operator, right? So if column index modulo three is equal to 0 and row index modulo 3 is equal to 0, then we're in the first box. So if number in box 1 return false, okay? Else we will box 1 dot add number, okay? Then what do we need to do? Do the same thing here. And now if this one is equal, so if the column index, so column is like this one, right? So if this one is equal to, we're moving over 1, but row is still the same. Now we're in box 2. So this will be box 2 and box 2, okay? Now, if it's equal to 2, we're in box 3 and 3, okay? So this will be box 4 right here. And now we want this to be 0 and this one to be 1. And that means that this is going to be 4 and 4. Now this is going to be 1. This is going to be 5, and this is going to be 5. So now this one increases again. This is 2. This is going to be 6. And this is going to be 6. Okay? This is going to increase. No. This one is going to increase. So now this one increases. This one gets reset back to 0. This one is going to be 7, and this one is going to be 7. Yeah. So this one is going to increase, this one is going to go up to 8, and this one's going to go up to 8. All right, final one. So this one is going to increase, this one is going to increase to the box 9, this one is also going to increase. Now, if we have successfully gone through all the rows and all the columns, okay, so we need to get back to this index here. So if we've done all of that, is it this one? Then we can return true. Let's run this and see. All right, I'm gonna submit it just because I want to kind of keep record of what I did, but that was my attempt. I don't know. Okay. True. Okay. So let's just go to the solution. So essentially we failed. I was not able to get the correct answer, and so first off, I was not able to even think of an efficient answer at all. Everything about it seemed terrible, the way that I was doing it. Plus, it didn't even work. So I failed on both accounts. Awesome. Okay. So here. This is the brute force right here. And for row in range 9, so we're going through 9 rows. Oh, okay, well that kind of makes sense. So the way that he's doing it here is we go through each row and we just create a new set each time called scene. And so that way we're not creating that huge, we're not doing what I did up here, which was so stupid of me, of just creating a trillion different sets. He just reuses the same set each time, each row by row by row. Okay, yeah. So if it's a dot, you don't do anything. Okay, that makes sense. If it is, so if it's already seen, then you return false, or then you add it. Okay, so I did something similar to that. His is just more efficient. For column in range, and then he's doing the exact same thing for the column. So let's see, for square in range, 9. Okay, so he's going through 9 squares, creating a new set. So for I and J, so 3 by 3, row is equal to square, integer division 3, multiplied by 3, plus I. Okay. Column is that, so this just identifies what row and column. So we're just going through each of the squares and getting the rows and columns. Okay, whatever. And then just doing the same thing. Okay, fine. Of n squared. So this is... I'm not sure why it's O of n squared, because we are... So this is just looping through one of the three, so it's... And it's for each square, which is a subset of... So we're only for example, this line of code is only going to get hit 9 times, right? Because it's 3 times 3. 9. And 9. Okay, so... Sorry, it's not going to be 9, obviously. But it's going to be n, where n is the number of total elements. So why is it of n squared? Each of these is O of n, right? This is O of n. This is O of n. This is O of n. So the entire thing should be O of n. I don't get why it's O of n squared. I don't know. Hash set. Okay, so... Column is default dictionary set. Default dictionary set. Okay, squares. So we're creating a dictionary, and in the dictionary, its elements is a set? For row and column, so we're going through 1 through 9. So if and then we're just checking if it's in the row and I don't know, man. I don't know. And then we return. Okay, fine. If it's in it, we return true, or false. If it's not, we return the other one. Okay, whatever. Bit mask. They're all O of n, so I don't know. What the heck is going on here? We're creating a list of 9 zeros, so it's 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. So for okay, I don't think this one is a reason. This method, this bit mask, I don't think is a very reasonable solution. Like, how would you ever think to do something like this? I don't know. Are you literally like bitwise shifting over? Yeah, okay. Well, I'm not even gonna look at that. That this one doesn't apply to me. That didn't make any sense. So this one right here, this one actually applies to me because it's like I need to know how to use it, and I didn't know that you can have like a default dictionary of set elements. I thought that it was only like integers or strings or something like that, but apparently you can have it of sets. So I didn't know that you could do that. I don't know why mine didn't work. I probably did something stupid, like some random thing. But yeah, so not great. Yeah, not too honestly not too satisfied with my performance today on this question. So that's unfortunate, but I am going to return tomorrow and maybe try to do this problem again and see if I can come up with those two solutions that I saw tonight. So I'm going to put it in my head, sleep on it, and then hopefully tomorrow I can I can think of these two solutions here. Then, yeah, that'll be my video tomorrow. And maybe if I have a fresher mind, I can think about what's going on here, and then, yeah, I'll probably watch this video as well tonight. I would watch it, like, in this video, but I don't know about the copyright question, like, because I'm posting this on YouTube, but then I'm watching someone else's video, so it's like, it's his copyright, but anyways, so I'll probably watch this video tonight. I'm getting pretty tired. It's almost 1 a.m., and I had a pretty productive day at work. I was pounding through a lot of like embedded systems and trying to get anyways, I can't talk too much about like what specifically I do at work, obviously, but just like embedded system stuff. So, but I made a lot of progress. My brain is kind of shot from that, and then I did another video which was the software engineering, like back-end software engineering project. So now I'm doing this video, but yeah, not too happy with my. Okay. Anyways, yeah, hope you guys enjoyed this video. If you did, subscribe. I will see you tomorrow. And one other thing, thank you guys so much for the. Let me refresh it. Thank you guys so much for the like, I just hit 1,000 subscribers, so thank you so much for that. That is amazing. And yeah, I hope you have a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you tomorrow.